Okay, suppose SpaceX, a 3,800,000 kilogram rocket with a drag coefficient of 0.95 enter Mars atmosphere in a belly flop position. So that's going to be like this. So here's the rocket, and it's falling that way. So it has as much surface area towards as possible, as much surface area as possible to maximize friction. Okay, so this surface area is actually 600 square meters right here. What is the terminal velocity of the spaceship? So remember, to get terminal velocity, we need this force drag equation, and understand that the force of gravity, by the way, this is the force of Mars gravity now, force of gravity is equal to the force drag. So what is the force of gravity for this 3,800,000 kilogram rocket ship? Well, that's going to be mass times acceleration due to gravity, right? So that's going to be 3,800,000 multiplied by acceleration due to gravity on Mars. So what is the acceleration due to gravity on Mars? Go ahead and check that out. Go ahead and look it out. All right, if you look it up, you'll find that it's 3.7 meters per second squared. Now go ahead and multiply those two together. And we get this number right here. All right, and that should be in newtons. Now remember, the force drag needs to also be this number since we're at terminal velocity. So we can change this one to force gravity equals 1/2 QC AV squared. So force of gravity, that's about 14 million. It's supposed to be a 6. Equals 1/2. What's that Q value? Remember, the Q value is the density of the fluid, and so for Mars it's less than Earth. I think it's 0.7. Let's make sure. Oh, 0.55. 0.55. Okay, so it's about half as dense as Earth. So 0.55, and now we're looking for the C value, or the drag coefficient. What is that? Well, it's right here. They just give it to us in the problem. Okay, so then we multiply it by 0.95, and then the area, we already talked about that one, that's 600. And then finally V squared. So that's what we're solving for. So simplify both sides. First thing I'm going to do is I'm going to get rid of the fractions. So I'm going to multiply both sides of this equation by 2. Okay, so if I multiply this side of the equation by 2, this is gone. And then this right here needs to be the left side needs to be multiplied by 2. So that's going to be, just using my calculator, 2, 8, 1, 2, and then 4 zeros. Let's see if that makes sense. Yes, 14, 28, or you get a 1, 4 here and a 28 here, so it makes sense. Okay, now what I'm gonna do is I'm just gonna multiply all these three together, and I get 0.55 times 0.95 times 600. And I get 313.5. All right, v squared, divide both sides by 313.5, and we got it. Okay, I just divided both sides by 313.5, and so then I end up with v squared equals 89696. All right, take the square root of this, and I end up with about 300 meters per second. Now I made a mistake. What mistake did I make? Well, when you take the square root, remember it's plus or minus. We gotta choose plus or minus. So we choose negative because it's going downwards. Okay, so the terminal velocity is negative 300. We got it. So in the next problem here, we're gonna use this number to answer this question. All right.